Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We are going to present our project about the vibration of coupled system. So our group member is Muhammad Fahim bin Musa, Muhammad Hafiz bin Ramli and Muhammad Farhan Hazmi bin Jaafar. For introduction, we study at linked system oscillatory behavior. The oscillatory motion of a linked system's parts causes a vibration which can have a big influence on the efficiency and dependability of the whole. The total stiffness and vibration properties of a mechanical system can be impacted by coupling between two or more mechanical systems. This is crucial for designing and analyzing mechanical structures, since stiffness and vibration behavior may significantly affect the efficiency and dependability of a system. The study's finding will be helpful for a certain kind of system or an issue in the real world.
Next is mathematical formulation. A mathematical formulation for the vibration of a coupled system can be derived using the equations of motion and the properties of the system. For example, consider a coupled system consisting of two masses, M1 and M2, connected by a spring with spring constant K. The equations of motion for this system can be written as M1 x1 double prime equal to negative K1 x1 plus K2 times x2 minus x1, and the second equation is M2 x2 double prime equal to negative K2 times x2 minus x1, where x1 and x2 are the positions of masses M1 and M2 respectively.
Now we will look at the problem that we want to solve. So this is the problem that we will going to solve. On a smooth horizontal surface, a mass M1 is equal to 2 kg is attached to a fixed wall by a spring with spring constant K1 is equal to 4 Newton meter, and the mass M2 is equal to 1 kg is attached to the first object by a spring with spring constant K2 is equal to 2 Newton meter. The objects are aligned horizontally so that the springs are their natural lengths. You can see the figure. If both objects are placed 3 meter to the right of their equilibrium position and then release, what are the equations of motion for the two objects? So this is the figure. We need to calculate the equation that will represent the motion of these two objects. Now we go to the result and also the discussion. This is the general system of the second order ED for the coupled system, which is this one. M1 is equal to M1 d2x dt square is equal to F1 plus F2 minus K1x plus K2y minus x, and M2 is equal to 2y dt square. F3 is equal to F3 and minus K2 y minus x. So F1 is given, this force is given by this expression, and this F2 is given by this expression. You can see M1 will be equal to the mass for the first load, and M2 is the mass for the second load, and we substitute M1, M2, K1, K2 into the system of equation, and we have this system. And also we need to consider the initial condition, and then we need to convert this system of second order ODE into system of first order ODE. To do so, therefore we need to introduce a new variable, which is y1 is equal to x1 and y3 is equal to x2. So therefore we have four equation, which is, but it becomes system of first order ODE, and we have this matrix. So next we are going to find the eigenvector, the eigenvalue of the matrix. We need to compute the eigenvector for the matrix A, and of course in order to do so, before we compute the eigenvector, we need to compute the eigenvalue first, which is this matrix. Then we need to minus the diagonal by lambda, and we will get the polynomial, and then we factor out factoring our polynomial in this form, and we will get the value of lambda is equal to plus minus I, and also lambda is equal to plus minus 2I. And then we need to compute the eigenvector for lambda is equal to I and lambda is equal to 2I. This one is lambda for lambda 1 is equal to I, and this one is lambda 2 is equal to 2I. Then we will make the augmented matrix from the system, and then we are going to and then we have the eigenvector, which is this one, and then we proceed with finding the eigenvector. No, this is the eigenvector, and then the general solution of the system is this one. We have the general solution. So now we need to find the exact solution. In order to do so, we need to substitute the initial condition. This is the initial condition, and we have the constant coefficient C1, C2, C3 and C4. We substitute back into our general equation. Therefore we have this solution, which is taken from the first and third row. From here we have this one, and this is the computer aided solution. We use Maple to compute it, and it will output this result, which is the same as our manual solution. And this one is the graph for the solution.
And the last one is conclusion and recommendation. The study's main discovery was the natural frequencies of the system are the eigenvalues of the eigenvalue equation, and they represent the frequencies at which the system will vibrate when it is excited. The behavior of the system may be considerably impacted by the coupling between the various components. It was discovered in the research of the vibration of linked systems. The stiffness and mass of the components, as well as the kind and strength of the coupling, are all factors that affect how the system responds to the vibration. The model should consider coupling effects when examining the vibrational behavior of linked systems according to these findings. To correctly depict the interaction between the components, this may necessitate using sophisticated modeling techniques. Overall, the study of the vibration in coupled systems is a challenging and major area of research, having vital applications in areas including robotics, mechanical designs, and structural engineering.
That's all from us. Thank you for watching.